Hello and welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 200, number of islands. So for this problem, you're given an M by N 2D grid, which represents a map of land and water. And so the land is going to be represented by a 1, and water is represented by a 0. And you need to return the number of islands. So an island is a group of ones that are surrounded by zeros. So you can see in this example 1, this is an island because the ones are all surrounded by zeros, and you can assume that the ends of the boundaries of the array are also surrounded by zeros. So you can pretend there's zeros all like this. So if you look at it like that, you can see that there is one island because there's a group of ones there's one group of ones that are surrounded by zeros. And if you take a look at example 2, if there were zeros surrounding like this, you can see that there's one island here, there's one island here, and there's one island here. So there's 3 islands because there's 3 groups of ones that are surrounded by zeros. And when we say surrounded, we mean 4 directionally surrounded, so up, down, left, and right. You can see that these 2 islands right here are not connected because they're diagonally across from each other. The ones are diagonal from each other, and we're not counting diagonals. So those islands are not connected. They're 2 separate islands instead of 1. So it is pretty straightforward if you're looking at the array, the array of arrays, and it's pretty straightforward to count the islands by looking at it. But how can we do this programmatically? Well, one thing that we can do is we can look for a 1. We can scan the array or the grid. We can scan the grid, and we can look for a 1. And then when we find that 1, we can go in all directions looking for other ones. So you can go up, down, left, and right. And if you find a 1, then you add that to the island, and you start looking up, down, left, right, in from that 1, and then you look up, down, left, right in that 1. So basically, if you start from a 1 and you look for 1s in all directions, that approach would be a depth first search. So this is a graph algorithm. That would be a depth first search approach. And that's exactly what we can do to solve this problem. We can look in all directions and see if we can find a 1 And if we find a 1, we look in all directions from that 1 until we hit a 0, or we're out of bounds. And what we also want to do is make sure that we only visit a 1 once. So we want to only visit each one time. So we want to keep track of the ones that we've already seen. So we can use a set to keep track of the ones that we've already seen. And we can just count the number of depth first searches that we had to do. So we count number of depth first searches that we had to do, and that is the number of islands. Basically the number of times that we had to do a new depth first search. So if you did a depth first search and you found this 1, and then you continued on looking up, down, left, and right, this wouldn't be a new depth first search. So this would be connected to this original depth first search. So this would only count as 1 island. So that is that's the basic algorithm for solving this problem. So you do a depth first search whenever you find a new 1, and you count the number of times that you had to do that, and that is the number of islands. So let's take a look at how to code that. So the first thing you need to do is get your dimensions of your grid. So the number of rows is going to be equal to the length of the grid, and the number of columns is going to be equal to the length of one of the grid rows. And now you have your rows and columns, and now you also need a set that we were talking about to keep track of which things that you visited, which ones that you visited. So you can make a new set for that. And now we'll define our depth first search function, and we'll call it is new island. And basically this is going to find and mark an entire island, and we're going to pass it a row and a column. So we're going to pass it a row and a column, which is the position in the grid. So first we need to take care of the base cases for this recursive depth first search function. So first thing is that if the row is out of bounds, so if the row is less than 0 or the column is less than 0, then that means we've gone too far to the left or we've gone too far up. So if the row is less than 0 or the column is less than 0, or the row is greater than or equal to the number of rows, then we've gone too far, or the column is greater than or equal to the number of columns, then we've gone too far. Or, so these are all things that we want to, this is not going to be a valid state, so we want to skip. And so the next thing is that if this is a 0, if this is not a land, if this is water, then so if grid at RC equals 0, or what if we've already visited this, we've already seen this before, so if RC, so in our visited set, we're going to keep coordinates RC, and that is going to mean that we've seen the coordinates before. We visited this row and this column, so RC in visited. Then if any of those are true, then we want to return false, because this is new island is going to return a Boolean. It's going to return true if this 1 is, and this 1 is an island that we found. We've found this 1 and we've gone to all the other ones that are connected to it, and that whole thing is an island. So it's not an island, it's not a new island if it meets any of those conditions. And otherwise, what we want to do is, that means if it hasn't hit any of these, then it's going to be a 1, and it's going to be a 1 that we haven't seen before. So what we want to do is add this to our visited set. So we're going to say visited dot add RC, and then we're going to go up, down, left, and right, and we're gonna look for the rest of the island. So we're gonna call isNewIsland on the row and column. We're gonna change that, and we're gonna call this in all directions. So we're gonna call this in all directions. So this is how you can go in all directions. You increase the row, you decrease the row, and then you increase the column and you decrease the column. So after you go in all directions, then you can actually return true, because this is the end of the depth first search function. You have found, using these recursive calls, you have gone in all directions, finding all the island, all the ones connected to this. So basically all the parts of the island. And so at the end, you can return true that this was a new island. And then, so that's the end of this depth first search function. So now that we've defined this function, we want to call it. So we're going to iterate for R in range num rows. We're going to iterate through all the rows and columns. So we're going to iterate through the grid for R in range num rows and for C in range num columns. And we're going to say if our grid at RC is equal to a 1, then we want to start our depth first search. And if this returns true, if isNewIsland if this returns true, then we're going to count. So num islands, we're going to make a variable for that and initialize it to 0. And if this is, we've found one island and we finished doing a depth first search on it, then we want to increment num islands. And that is it. And then we want to return num islands. So basically we're going to start at an island. We're going to start at a land, and we're going to do our depth first search, and we're going to be marking all of the land as visited. So when we run this iteration and we get to that land, it's not going to count that as a new island if it was already visited. So that way we only are counting each new island. So that is the code. And so let's run this and see what happens. And so we've got a invalid syntax. I forgot this in right here. And this is giving us a incorrect answer. Actually, the ones in there are strings, not numbers, so we need to take care of that. And this 0 should be a string also. And is there any other typos in here? Okay, so let's run this. And I misspelled visited. Sorry about that. And it's giving us the right answer. So let's submit this. And it was accepted, and it is pretty fast, faster than 81%. So that is the way you solve the number of islands using depth first search. And you're only having to visit each element in the grid one time because you're having this visited set. So this algorithm will run in m times n time complexity because you only have to visit each element one time, up to one time. So thanks for watching, and I'll see you in the next video.